What if I told you that right now, as you're listening to this, there's another version of you lying on the other side of your bed, not metaphorically, but literally existing in the same space, breathing the same air, yet completely invisible to you? What if every choice you didn't make tonight created a universe where you did make it, and in one of those realities, you chose to sleep on the opposite side? This isn't science fiction. According to quantum mechanics' most mind-bending interpretation, infinite versions of you are experiencing infinite variations of this very moment, all superimposed in the same location, all equally real. Chapter 1. The Quantum Mirror of Reality. In 1957, a 27-year-old graduate student named Hugh Everett III submitted a doctoral dissertation that was so radical, so disturbing to the scientific establishment, that it nearly ended his physics career before it began. His advisor, the legendary physicist John Wheeler, was so concerned about the implications of Everett's work that he heavily edited the original thesis, removing the most controversial sections before allowing it to be published. What had Everett discovered that was so threatening to the world of physics? He had found a way to solve one of quantum mechanics' most troubling puzzles, but his solution was more unsettling than the problem itself. Everett proposed that every time a quantum event occurs, the universe doesn't choose a single outcome. Instead, it splits into multiple parallel realities, each one experiencing a different result. In other words, every possible outcome of every quantum event actually happens, just in separate universes that we can't see or interact with. This idea emerged from one of the strangest puzzles in all of science, a thought experiment proposed by Austrian physicist Erwin Schrödinger in 1935. Schrödinger was trying to illustrate what he saw as the absurdity of the prevailing interpretation of quantum mechanics, known as the Copenhagen interpretation. He imagined a cat sealed inside a box with a radioactive atom, a detector, and a vial of poison. If the atom decays, it triggers the detector, which breaks the vial and kills the cat. If the atom doesn't decay, the cat stays alive. According to quantum mechanics, the radioactive atom exists in what physicists call superposition. It's both decayed and not decayed simultaneously until someone observes it. The Copenhagen interpretation suggested that this superposition somehow extends to the entire system, meaning the cat would be both alive and dead at the same time until someone opens the box to check. Schrödinger thought this was ridiculous. How could a cat be both alive and dead? Where's the boundary between the quantum world of strange superpositions and our everyday world of definite outcomes? This became known as the measurement problem, and it plagued physicists for decades. Most physicists accepted the Copenhagen interpretation despite its weirdness. They believed that the act of observation somehow caused the quantum superposition to collapse into a single, definite outcome. The cat became either alive or dead the moment someone looked. But this raised even more troubling questions. What counts as an observation? Does it require consciousness? How does the quantum system know it's being observed? Hugh Everett had a different answer, one that was both elegant and terrifying. He suggested that the superposition never collapses. The cat doesn't become either alive or dead. It becomes both alive and dead, but in separate universes. When you open the box, you don't force the cat into a single state. Instead, you split into two versions of yourself. One who sees a living cat and one who sees a dead cat. Both versions are equally real, but they exist in parallel universes that can no longer interact with each other. This means that right now, as you're lying in bed listening to these words, there are countless parallel versions of you experiencing slightly different variations of this moment. In some universes, you chose to lie on the left side of your bed. In others, you're on the right side. In still others, you're sitting up or lying on your stomach, or decided not to listen to this at all. Each version of you feels completely normal and thinks they're the only real version. But, according to Everett's many worlds interpretation, they're all equally real. The branching happens constantly, trillions upon trillions of times per second, every time a quantum event occurs anywhere in the universe. Every time an electron in your brain takes one path instead of another, every time a photon of light reflects off an object in a particular way, every time a radioactive atom in your body decays, all of these quantum events create new branches in the ever-expanding tree of parallel realities. But here's what makes this even stranger. The process that creates these parallel worlds is the same process that makes them invisible to each other. It's called quantum decoherence, and it's why you don't see cats that are both alive and dead, or experience the ghostly presence of your parallel selves. When quantum systems interact with their environment, they become entangled with countless other particles. This entanglement spreads like ripples in a pond, quickly involving so many particles that the different quantum states become isolated from each other. Each branch of reality becomes its own coherent world, unable to interfere with the others. Think of it like radio stations. All the radio waves are traveling through the same space at the same time, but your radio can only tune into one frequency at a time. The other stations don't disappear, they're still there, broadcasting their programs simultaneously. You just can't hear them, because your radio isn't tuned to their frequency. In the same way, all the parallel universes exist in the same space, but quantum decoherence ensures that each one can only experience its own reality. This explains why quantum mechanics seems so different from our everyday experience. At the microscopic level, particles can exist in superposition because they haven't yet become entangled with enough other particles to trigger decoherence. But once a quantum system becomes large enough and complex enough, decoherence happens almost instantaneously, splitting the universe into separate branches and giving each one the appearance of classical, definite outcomes. Your brain, with its billions of neurons and trillions of quantum interactions, is constantly triggering decoherence events. Every thought you think, every decision you make, every random neural firing creates new branches in the quantum multiverse. The version of you experiencing this moment is just one thread in an infinite tapestry of parallel selves, each one convinced that their own experience is the only real one. Everett's interpretation was so radical that most physicists initially ignored or rejected it. The idea of infinite parallel universes seemed like science fiction, not serious science. Everett himself became so discouraged by the lack of acceptance that he left academic physics entirely and went to work for the Pentagon, where he helped develop nuclear strategy during the Cold War. But over the decades, more and more physicists have come to believe that Everett was right. The mathematics of quantum mechanics naturally leads to the many worlds interpretation when you take it seriously, and don't add extra assumptions about wave function collapse. Today, surveys suggest that many worlds is one of the most popular interpretations among professional physicists, even though its implications remain as mind-bending as ever. The measurement problem that Schrödinger's cat was meant to illustrate doesn't really go away in the many worlds interpretation. It transforms into something even more profound. Instead of asking how observation collapses the wave function, we have to ask how consciousness navigates through an ever-branching multiverse of parallel realities. Instead of wondering how quantum systems know they're being observed, we have to wonder how you can feel like a single, continuous self when you're constantly splitting into multiple versions. These questions lead us deeper into the mathematical structure of the multiverse, where the very concept of you becomes as strange and wonderful as quantum mechanics itself. Every choice not made, every path not taken, every random event that could have gone differently, they all exist somewhere in the infinite library of parallel worlds. And understanding how this cosmic splitting works requires us to dive into mathematics so bizarre it makes Schrödinger's cat look perfectly normal. Chapter 2. The Mathematics of Infinite You. The moment you decided to listen to these words instead of rolling over and going to sleep, the universe split. In one branch, you're here with me, exploring the deepest mysteries of reality. In countless others, you chose differently. You turned off the audio, checked your phone, got up for a glass of water, or simply drifted into dreams. All of these versions of you exist simultaneously, each one convinced they made the only choice that matters. But here's what will truly stagger your mind. The mathematics of quantum mechanics tells us that these aren't just poetic metaphors. If the many worlds interpretation is correct, there are literally infinite versions of you experiencing infinite variations of this moment. Not just a lot of versions, infinite versions. And the numbers involved in this cosmic splitting are so vast they border on the incomprehensible. Let's start with something seemingly simple. Right now, in your brain, there are approximately 86 billion neurons. Each neuron is firing or not firing, creating electrical patterns that generate your thoughts, memories, and consciousness itself. But at the quantum level, each of these neural firings involves countless quantum events, electrons tunneling through synapses, photons interacting with molecules, radioactive atoms in your body randomly decaying. Every single one of these quantum events occurs at the smallest meaningful scale in physics, called the Planck scale. At this level, time itself becomes granular, divided into units so small that in 1 second there are approximately 10 to the power of 43 Planck time units. That's a 1 followed by 43 zeros, a number larger than the total number of atoms in the observable universe. During each Planck time unit, quantum events are happening throughout your body and brain. Your neurons contain countless molecules, each made of atoms, each atom containing particles that exist in quantum superposition until they interact with their environment. When these interactions occur, they create what physicists call measurement events, moments when the universe must choose between different quantum possibilities. According to the many worlds interpretation, the universe doesn't actually choose. Instead, it splits into parallel branches, each one experiencing a different outcome. This means that in every Planck time unit, and remember, there are 10 to the power of 43 of these every second, reality is branching into multiple parallel versions. The physicist Max Tegmark calculated that a human brain experiences approximately 10 to the power of 50 quantum events per second. Each of these events potentially creates a new branch in the multiverse. This means that every second you're alive, you're splitting into approximately 10 to the power of 10 to the power of 50 different versions of yourself. To put this in perspective, this number is so large that if you tried to write it out, You would need more digits than there are atoms in the observable universe. But this raises a profound question. If you're constantly splitting into infinite versions, what makes you feel like a single, continuous person? Why don't you experience the chaos of multiple realities simultaneously? The answer lies in a process called quantum decoherence, one of the most important concepts in modern physics. Quantum decoherence is like a cosmic sorting mechanism that keeps parallel universes separate from each other. When quantum systems interact with their environment, they become entangled with countless other particles. This entanglement spreads rapidly, creating what physicists call an entanglement network that isolates each branch of reality from all the others. Think of it like this. Imagine you're in a vast library with infinite floors, each floor containing slightly different versions of the same books. You can only read the books on your floor, because the stairways between floors are blocked by quantum decoherence. The other floors exist. In fact, there are infinite versions of you reading infinite variations of these same books on every floor, but you can't access them or even know they're there. This isolation happens almost instantaneously for macroscopic objects like your brain. While individual particles can maintain quantum superposition for extended periods, complex systems with many interacting parts undergo decoherence in incredibly short timescales, often in less than a trillionth of a second. This is why you experience classical reality instead of quantum strangeness in your daily life. But here's where the mathematics becomes even more extraordinary. Not only are you constantly splitting into infinite versions, but each version is also connected to all the others through what physicists call quantum entanglement. At the moment of splitting, all your parallel selves share the same quantum history. You're like identical twins separated at birth, carrying the same genetic information, but experiencing different lives. This connection between parallel selves explains something remarkable about quantum mechanics called the principle of unitarity. This principle states that information is never truly lost in quantum systems. It's just redistributed across parallel branches. When you make a decision, the information about the choice you didn't make doesn't disappear. It continues to exist in a parallel universe where another version of you made that choice instead. The mathematician and physicist Max Tegmark has proposed that this branching structure isn't just a feature of quantum mechanics. It might be the fundamental nature of reality itself. In his mathematical universe hypothesis, Tegmark suggests that all mathematical structures that can exist actually do exist as physical realities. This would mean that the many worlds interpretation is just one example of a much larger multiverse containing every possible mathematical structure. If Tegmark is right, then the parallel versions of you aren't just created by quantum splitting. They exist because mathematical consistency demands that all possible variations of you must exist somewhere in the vast landscape of mathematical reality. You're not just one person who happens to split into multiple versions. You're one member of an infinite family of mathematically possible beings, all equally real, all experiencing their own versions of existence. This mathematical perspective reveals something profound about the nature of identity across the multiverse. Each version of you maintains what physicists call a coherent world line, a continuous thread of experience that feels unbroken and singular. Your memories, personality, and sense of self remain consistent within each branch, even as countless other versions of you experience different memories and develop different personalities based on their unique quantum histories. The process that maintains this coherence is deeply connected to the way biological systems process information. Your brain isn't just a classical computer running software. It's a quantum information processor that creates and maintains your sense of identity through the complex interaction of quantum and classical processes. Recent research in quantum biology has revealed that biological systems routinely exploit quantum effects for enhanced efficiency. Photosynthesis in plants uses quantum superposition to explore all possible energy transfer paths simultaneously, selecting the most efficient route. Bird navigation systems use quantum entanglement to detect magnetic fields with extraordinary precision. Your own consciousness might be using similar quantum processes to navigate through the branching structure of the multiverse. This raises a fascinating possibility. Perhaps your consciousness doesn't just passively experience one branch of reality after another. Perhaps it actively participates in the branching process, using quantum effects in your neural microtubules to influence which branches become accessible to your experience. Some physicists have suggested that consciousness might be nature's way of exploring the space of quantum possibilities, with each conscious observer serving as a kind of quantum navigator, charting courses through the infinite landscape of parallel worlds. The implications for your sense of self are staggering. If consciousness actively participates in quantum branching, then your choices and experiences aren't just the result of classical brain processes. They're manifestations of quantum information processing that spans multiple parallel realities. Every decision you make ripples across countless parallel versions of yourself, creating a vast network of interconnected experiences that collectively define who you are across the multiverse. But this also means that the question, how many versions of you exist, doesn't have a simple answer. In one sense, there are infinite versions because quantum branching is continuously creating new parallel realities. But in another sense, all these versions are aspects of a single, larger identity that exists across multiple dimensions of quantum space. Modern quantum field theory provides an even more extraordinary perspective on this question. According to the mathematical framework that describes fundamental particles and forces, reality consists of quantum fields that permeate all of space and time. Particles aren't separate objects moving through empty space. They're excitations in these underlying fields, like waves on an infinite ocean. If consciousness emerges from the complex interaction of quantum fields in your brain, then your identity might be more like a wave pattern that can exist across multiple parallel realities simultaneously. The version of you that's listening to these words right now is just one manifestation of a much larger wave function that includes all your parallel selves across the quantum multiverse. This wave function perspective suggests that the boundaries between different versions of you aren't as clear-cut as they might initially seem. While quantum decoherence keeps parallel worlds from interfering with each other in obvious ways, subtle quantum correlations might still connect your parallel selves in ways that influence your experience without your conscious awareness. Some physicists have speculated that phenomena like intuition, creativity, and even dreams might involve weak quantum connections between parallel versions of yourself. When you have a sudden insight or creative breakthrough, you might be unconsciously accessing information from parallel selves who explored different thought patterns or made different discoveries. This possibility transforms the mathematics of infinite versions from an abstract theoretical concept into something with profound implications for how you understand your own mind and identity. You're not just one person among infinite alternatives. You're a conscious node in a vast network of quantum information processing that spans countless parallel realities. The numbers we've explored tonight reveal the true scope of this network. With 10 to the power of 10 to the power of 50 new versions of you being created every second, and with each version connected to all the others through quantum entanglement and shared history, you're participating in a form of existence so vast and complex that it challenges every assumption about what it means to be an individual conscious being. Yet despite this overwhelming mathematical complexity, you wake up each morning feeling like the same person who went to sleep the night before. This continuity of experience across quantum branching might be the most remarkable feature of consciousness itself, the ability to maintain a coherent sense of self while participating in the infinite creative exploration of quantum possibility space. As we prepare to explore how these quantum splits actually occur in the physical processes of your brain and body, remember that every word you've just heard represents a choice among infinite alternatives. In countless parallel realities, different versions of you focused on different aspects of this explanation, understood different implications, or chose to stop listening entirely. But the version of you that's here right now, contemplating these extraordinary mathematical realities, is about to discover how the quantum mechanisms of splitting work at the most intimate level of your biological existence. Chapter 3. When Reality Splits, the Moments That Create New Worlds. 3 minutes and 17 seconds ago, a single radioactive carbon-14 atom in your left lung randomly decayed. In that instant, the universe split into 2 branches. In this reality, the decay released a beta particle that traveled through your lung tissue and was absorbed harmlessly. In a parallel reality, the atom didn't decay, and a slightly different version of you continues breathing without that particular quantum event ever occurring. Both versions of you feel completely normal, completely real, and completely unaware that this cosmic division just took place. This is how reality splits, not through dramatic choices or life-changing decisions, but through countless microscopic quantum events happening inside your body every fraction of a second. Your very existence is a continuous cascade of universe-creating moments, each one so small and subtle that you never notice them, yet each one fundamental enough to spawn entire parallel worlds. To understand how these splits occur, we need to peer into the quantum machinery of life itself. Your body contains approximately 7 octillion atoms. That's 7 followed by 27 zeros. Each of these atoms is composed of particles that exist in quantum states, constantly interacting with their environment through processes that trigger the branching of reality. The most frequent splitters are the quantum tunneling events that occur in your cellular chemistry. Every time an enzyme in your body facilitates a chemical reaction, electrons must tunnel through energy barriers that classical physics says should be impossible to cross. Quantum mechanics allows these particles to essentially teleport through barriers, but the exact timing and location of these tunneling events are fundamentally random. Consider what happens when you digest the food you ate earlier tonight. Inside your stomach and intestines, billions of enzyme molecules are breaking down complex nutrients into simpler compounds your cells can use. Each enzyme works by lowering the energy barrier that prevents chemical reactions from occurring spontaneously. But at the quantum level, the electrons that facilitate these reactions don't smoothly climb over the energy barriers, they tunnel through them in quantum leaps that occur at unpredictable moments. Every tunneling event creates a branching point. In some universes, the electron tunnels through immediately, causing the chemical reaction to proceed quickly. In others, there's a slight delay, creating small variations in the timing of your digestive processes. These tiny differences cascade through your metabolism, affecting everything from your blood sugar levels to the electrical activity in your brain. The quantum effects become even more pronounced in your nervous system. Each of your 86 billion neurons communicates through synapses, tiny gaps between brain cells where chemical signals jump from one neuron to another. These synaptic transmissions depend on quantum processes that are exquisitely sensitive to random fluctuations. When a neuron fires, it releases neurotransmitter molecules into the synaptic gap. These molecules must bind to receptors on the receiving neuron, but the binding process involves quantum interactions between electrons in the neurotransmitter and electrons in the receptor protein. The probability of successful binding depends on quantum factors that can vary randomly from one moment to the next. This means that the exact pattern of neural firing in your brain, the physical basis of your thoughts, emotions, and decisions, is constantly being influenced by quantum randomness. A neuron that fires in this universe might not fire in a parallel universe where the quantum interactions played out slightly differently. The thoughts you're thinking right now, the way you're processing these words, the emotional responses you're having, all of these are shaped by quantum events that create parallel realities where your mental state is subtly different. But perhaps the most profound quantum splitting occurs in the microscopic structures within your neurons themselves. In 1996, physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed that consciousness might arise from quantum processes occurring in cellular structures called microtubules. These protein frameworks, which exist inside every neuron, might be capable of maintaining quantum coherence at body temperature, something most scientists thought was impossible in the warm, noisy environment of living cells. According to the Orchestrated Objective Reduction Theory, or ORC-OR, microtubules can exist in quantum superposition states where they simultaneously explore multiple computational possibilities. When these superpositions collapse approximately 40 times per second, they create discrete moments of conscious experience. Each collapse potentially creates a branching point where different quantum outcomes generate parallel streams of consciousness. If ORC-OR theory is correct, then your consciousness isn't just influenced by quantum effects, it's directly generated by quantum processes that constantly split reality into parallel branches. Every moment of awareness, every thought, every conscious decision emerges from quantum events that create new universes where slightly different versions of consciousness unfold. This quantum splitting extends beyond your brain to affect every aspect of your biological existence. The DNA in your cells is constantly being damaged by cosmic rays, radioactive decay, and chemical interactions. Most of this damage is repaired by sophisticated molecular machinery, but the repair process itself depends on quantum interactions that can produce different outcomes. When a cosmic ray strikes a DNA molecule in one of your cells, it creates quantum damage that exists in superposition until the cell's repair mechanisms interact with it. In some branches of reality, the damage is perfectly repaired, leaving your DNA unchanged. In others, the repair process introduces small mutations that alter your genetic code in subtle ways. Over time, These quantum-induced genetic variations create parallel versions of you with slightly different biological properties. The implications become even more extraordinary when you consider reproduction and development. If you have children, the formation of their genetic code depends on quantum processes during meiosis, the cellular division that creates egg and sperm cells. Random quantum events determine which genetic variants get passed to your offspring, creating branching points where parallel versions of your children receive different combinations of genes. This means that in parallel universes you might have children who are genetically different from the ones in this reality. They might have different eye colors, different heights, different susceptibilities to diseases, or different cognitive abilities, all based on quantum randomness during the formation of reproductive cells. The butterfly effect amplifies these microscopic quantum events into macroscopic differences across parallel realities. A single quantum tunneling event in an enzyme molecule might slightly alter the timing of a chemical reaction. This tiny delay might affect the release of a hormone, which could influence your mood in a barely perceptible way. The mood change might affect how you respond to a conversation tomorrow, which could influence someone else's decision, which might ripple outward to affect countless other people's lives. Meteorologist Edward Lorenz first discovered this sensitive dependence on initial conditions when he found that tiny changes in weather data could produce dramatically different weather predictions. He famously suggested that a butterfly flapping its wings in Brazil could trigger a tornado in Texas weeks later. In the quantum multiverse, this butterfly effect operates on every scale, from the atomic to the cosmic. The radioactive atoms in your body provide some of the most clear-cut examples of quantum branching. You contain small amounts of naturally occurring radioactive elements like carbon-14 and potassium-40. These atoms decay according to quantum probability laws. Each individual atom has a precise mathematical chance of decaying in any given time period. But the exact moment of decay is fundamentally unpredictable. When a radioactive atom in your body decays, it releases energy and transforms into a different element. This process is purely quantum mechanical. There's no underlying mechanism that determines when decay occurs. The universe simply splits into branches where the atom decays at different times, creating parallel realities with slightly different radioactive histories. These decay events might seem trivial, but they can have cascading effects throughout your biological systems. A radioactive decay near a DNA molecule might cause a mutation. A decay in your brain might affect neural activity. A decay in your reproductive organs might influence hormone production. Each decay creates branching points where parallel versions of you develop along slightly different biological trajectories. The quantum splitting becomes even more remarkable when you consider that it extends beyond your individual body to encompass every living thing around you. The quantum events occurring in other people, in animals, in plants, and even in bacteria create branching points that affect the larger world you experience. A quantum tunneling event in a plant's photosynthesis machinery might slightly alter the amount of oxygen it produces. This tiny change could affect local air chemistry in ways that influence your breathing or the behavior of nearby animals. A quantum decay in a bacterium might affect its growth rate, potentially changing the microbial ecosystem in ways that eventually impact your health. The interconnectedness of these quantum effects means that reality splitting isn't just about your individual choices and experiences. It's about the collective quantum evolution of the entire biosphere. Every living thing is constantly creating branching points through quantum processes, and these branches intersect and interact in ways that create an incomprehensibly complex web of parallel possibilities. As you lie in bed tonight, quantum events are occurring throughout your body at a rate that defies imagination. Electrons are tunneling through cellular barriers. Radioactive atoms are randomly decaying. Microtubules in your neurons are cycling through quantum superposition states. Each event creates new branches in the ever-expanding tree of parallel realities. In some of these branches, you'll sleep peacefully through the night. In others, you'll wake up at different times, have different dreams, or choose to get up for different reasons. The quantum randomness in your brain's chemistry will create parallel versions of you with slightly different thought patterns, different emotional states, different responses to tomorrow's experiences. But the splitting goes deeper than conscious experience. In parallel universes, the quantum events in your digestive system will create different metabolic patterns. The radioactive decays in your bones will occur at different times. The quantum interactions in your immune system will produce different responses to the microscopic threats your body encounters every day. All of these quantum processes work together to create what physicists call the branching structure of the multiverse, an infinite tree of parallel realities where every quantum possibility is explored simultaneously. You're not just experiencing one thread of this vast tapestry. You're experiencing all of them. But quantum decoherence keeps each branch isolated from the others. This means that the moment you decided to listen to these words about quantum splitting, you triggered countless additional splits through the quantum processes in your brain that generated that decision. The very act of learning about parallel universes creates new parallel universes where your understanding develops in different directions. The profound irony is that by exploring these concepts, you're actively participating in the process you're learning about. Every quantum event in your neurons, as you contemplate these ideas, creates new branches where parallel versions of you understand or respond differently. You're both the observer and the observed, the student and the subject, the conscious being learning about consciousness, and the quantum system creating new realities through the learning process itself. Chapter 4. Quantum Archaeology, Finding Traces of Other Worlds. In a laboratory in Vienna, Austria, physicist Anton Zeilinger performed an experiment that shouldn't be possible according to our everyday understanding of reality. He took a single photon of light and measured one of its properties. Then, using a technique called quantum erasure, he retroactively changed whether that measurement had ever occurred. The photon behaved as if the measurement had never happened, even though the measurement device had already recorded a result and the data had been stored in a computer. This wasn't science fiction or a magic trick. It was a demonstration of one of quantum mechanics' most unsettling features: the ability of future events to influence past events in ways that challenge our basic assumptions about cause and effect. And, according to some interpretations, experiments like these might be giving us our first glimpses into the parallel worlds predicted by many worlds theory. The quantum eraser experiment works by exploiting a strange feature of quantum mechanics called delayed choice. When you set up the experiment in one configuration, photons behave like particles, creating a pattern that shows they traveled through the apparatus along definite paths. When you set up the experiment differently, the same photons behave like waves, creating an interference pattern that shows they somehow traveled along multiple paths simultaneously. But here's where it gets truly bizarre. You can decide which configuration to use after the photons have already passed through the apparatus. Your choice about how to analyze the results retroactively determines how the photons behaved in the past. It's as if reality waits to see what you're going to measure before deciding what actually happened. In the many worlds interpretation, this retroactive influence makes perfect sense. When the photon enters the apparatus, the universe splits into branches corresponding to all possible paths the photon could take. Your choice of measurement configuration doesn't change what happened in the past. It determines which branch of reality you'll observe. The other branches still exist. You just can't access them anymore. This suggests that quantum experiments might be windows into the branching structure of the multiverse. Every time physicists perform a quantum measurement, they're not just studying particles. They're navigating through parallel realities and selecting which version of events becomes part of their observed history. The implications become even more extraordinary when you consider experiments involving quantum entanglement. When two particles become entangled, measuring one particle instantly affects the other, regardless of the distance between them. Einstein called this spooky action at a distance, and thought it proved that quantum mechanics was incomplete. But modern experiments have confirmed that quantum entanglement is real, and it might be providing evidence for the existence of parallel worlds. In the many worlds interpretation, entangled particles aren't mysteriously communicating across space. Instead, they're connected through shared quantum histories that span multiple parallel universes. When you measure one entangled particle, you're selecting which branch of reality to observe, and this selection automatically determines the state of the other particle in that same branch. Recent experiments have pushed this idea even further. Physicist Yakir Aharonov and his colleagues have developed a technique called weak measurement that allows them to extract information about quantum systems without fully collapsing their wave functions. These weak measurements reveal strange properties that seem to exist only in the shadowy realm between quantum superposition and classical reality. In one remarkable experiment, researchers used weak measurements to track the paths of photons through a double-slit apparatus. Classical physics says each photon should go through one slit or the other. Quantum mechanics says each photon goes through both slits simultaneously. But weak measurements revealed something unexpected. The photons seemed to follow trajectories that were neither classical nor quantum, but something in between. These intermediate trajectories might be glimpses of how particles behave in parallel universes. When reality splits at the quantum level, the different branches don't separate instantaneously. There's a brief period during which the branches remain partially connected, and weak measurements might be detecting properties that exist across multiple branches simultaneously. The technique has revealed even stranger phenomena. In some experiments, weak measurements suggest that particles can have negative kinetic energy, travel backwards in time, or exist in multiple locations with different probabilities. These properties don't exist in any single branch of reality, but they emerge when you consider the interference effects between multiple parallel worlds. This has led some physicists to propose that weak measurements are actually detecting what they call shadow particles, ghostly remnants of parallel worlds that briefly interact with our reality before quantum decoherence separates the branches completely. If this interpretation is correct, then parallel universes aren't completely isolated from each other. They might influence our world in subtle ways that we're only beginning to understand. Another promising avenue for detecting parallel worlds involves the cosmic background radiation, the faint afterglow of the Big Bang that permeates all of space. This radiation carries information about the early universe, including potential signatures of interactions between parallel realities. In 2013, astronomers discovered an unusual feature in the cosmic background radiation called the cold spot, a region where the temperature is about 70 microkelvin colder than the surrounding area. Various explanations have been proposed, including the possibility that it's evidence of our universe colliding with a parallel universe during the early stages of cosmic expansion. If parallel universes exist as separate bubble-like regions in a larger multiverse, they might occasionally come into contact with each other. Such collisions would leave distinctive signatures in the cosmic background radiation, circular patterns of temperature variations that show where one universe brushed against another. Several research groups are now searching for these collision signatures, hoping to find direct evidence of parallel worlds. The search has revealed tantalizing hints. Statistical analysis of the cosmic background radiation has identified several circular patterns that might be collision signatures, though the evidence remains inconclusive. Future space telescopes, with higher resolution and sensitivity, might be able to definitively detect these patterns and prove that our universe is just one member of a vast multiverse of parallel realities. Perhaps the most ambitious proposals for detecting parallel worlds involve quantum computers. These devices exploit quantum superposition and entanglement to perform calculations that would be impossible for classical computers. But according to physicist David Deutsch, quantum computers might be doing something even more remarkable. They might be borrowing computational power from parallel universes. When a quantum computer performs a calculation, it creates quantum superpositions that exist across multiple parallel realities. The computer explores all possible solutions simultaneously, then uses quantum interference to amplify the correct answer while canceling out the wrong ones. Deutsch argues that this process requires computational resources from parallel worlds. The quantum computer is literally performing calculations across multiple universes and combining the results. If this interpretation is correct, then every quantum computer is a machine for detecting and interacting with parallel realities. As quantum computers become more powerful, they might provide increasingly clear evidence for the existence of parallel worlds. Some researchers have even proposed using quantum computers to send messages between parallel universes, though such experiments remain purely theoretical. The most controversial approach to detecting parallel worlds involves the quantum Zeno effect, the ability to freeze quantum evolution by making repeated measurements. Named after the ancient Greek philosopher Zeno, who proposed paradoxes about motion and time, this effect demonstrates that frequent observations can prevent quantum systems from changing state. In the context of many worlds theory, the quantum Zeno effect might allow conscious observers to influence which branch of reality they experience. By making rapid, repeated measurements of a quantum system, you might be able to select preferred outcomes and avoid unwanted branches of the multiverse. This has led to the disturbing thought experiment known as quantum suicide. The idea is that if many worlds is correct, consciousness always continues to exist in some branch of the multiverse, even in situations that would normally result in death. A conscious observer who repeatedly puts themselves in life-threatening situations that depend on quantum outcomes would always survive in some parallel reality, experiencing a form of quantum immortality. While this thought experiment remains purely theoretical and ethically problematic, it illustrates how the many worlds interpretation makes testable predictions about the nature of consciousness and survival. Some researchers have proposed less extreme versions of these ideas, using quantum Zino effects to test whether conscious observation can influence quantum outcomes in measurable ways. Recent advances in quantum technology have made some of these experiments possible. Researchers have demonstrated quantum Zino effects in laboratory settings, showing that frequent measurements can indeed freeze quantum evolution. They've also shown that the boundary between quantum and classical behavior depends on the type and frequency of observations, suggesting that consciousness might play a more active role in shaping reality than previously thought. But perhaps the most intriguing evidence for parallel worlds comes from quantum biology, the study of quantum effects in living systems. Over the past few decades, scientists have discovered that biological processes routinely exploit quantum phenomena for enhanced efficiency and performance. Photosynthesis in plants uses quantum superposition to explore multiple energy transfer pathways simultaneously, selecting the most efficient route with near-perfect accuracy. Bird navigation systems use quantum entanglement to detect magnetic fields with extraordinary precision. Even the sense of smell might depend on quantum tunneling effects that allow molecules to be identified by their quantum vibrational signatures. These biological quantum effects suggest that life itself might be a natural quantum detector, capable of sensing and responding to phenomena that exist at the boundary between classical and quantum reality. If parallel worlds influence our reality through subtle quantum effects, living systems might be the most sensitive instruments for detecting those influences. Some researchers have proposed that consciousness itself evolved as a biological mechanism for navigating the branching structure of the multiverse. In this view, conscious awareness isn't just an accidental byproduct of complex neural activity. It's a sophisticated quantum sensing system that helps living beings select favorable outcomes from the vast space of quantum possibilities. This perspective transforms the search for parallel worlds from a purely technological endeavor into a biological and psychological one. Instead of building more sensitive instruments to detect quantum effects, we might need to develop better understanding of how consciousness interacts with quantum reality. The evidence for parallel worlds might already exist in the form of intuition, creativity, dreams, and other aspects of mental experience that we don't yet fully understand. As you lie in bed, contemplating these possibilities, consider that your consciousness might be the most sophisticated quantum detector ever created by nature. Every thought, every decision, every moment of awareness might be sampling information from the vast network of parallel realities that quantum mechanics predicts. The evidence for other worlds isn't just hidden in exotic physics experiments. It might be woven into the very fabric of your conscious experience, waiting to be recognized and understood. The search for parallel worlds continues in laboratories around the globe, with each new experiment revealing more clues about the fundamental nature of reality. Whether through quantum computers borrowing power from other universes, cosmic telescopes detecting collision signatures in the sky, or biological systems sensing quantum effects beyond classical physics, we're gradually assembling evidence that the multiverse isn't just a theoretical possibility. It might be the deepest truth about the nature of existence itself. Chapter 5. The Geography of Parallel Selves. Imagine standing in the center of an infinite library. Every book that could ever be written exists somewhere on its endless shelves. Closest to you are books nearly identical to those you know, perhaps differing by only a single word or punctuation mark. As you wander further, the books begin to diverge, written in different languages, telling alternate stories, or proposing ideas that feel alien. This is what the geography of parallel selves resembles across the quantum multiverse. The you, listening to this right now, exists at the center of your own section in this infinite collection. Surrounding you are countless other versions of yourself, some nearly identical, others strikingly different, each existing in its own universe, branching off from quantum events. In the universes nearest to yours, the changes are microscopic. There is a version of you that shifted slightly 30 seconds ago. Another took one extra breath during the last sentence. These differences stem from minuscule quantum events. Perhaps a neuron fired slightly earlier, a molecule vibrated differently, or your heart beat a fraction of a second off rhythm. These nearby realities reveal that the multiverse has structure. It is not random chaos. It has a kind of topology. Universes with small quantum differences are your close neighbors. As changes accumulate, realities become more distant. The further you move from your current position in this quantum landscape, the more dramatic the variations become. A bit farther out, we find versions of you who made subtly different choices. Maybe you decided to lie on your back tonight instead of your side. Perhaps you listened to this chapter earlier in the evening, or chose a different chapter altogether. These small shifts still arise from quantum fluctuations, especially in the brain. A single neuron responding slightly differently can tilt your decision-making process, sending your life down a new path. These middle-range variations point to a striking idea. Free will may be deeply intertwined with quantum unpredictability. Every choice you make arises from a dynamic balance of neural signals. Quantum-level events can influence this process, creating a cascade that leads to different thoughts, different behaviors, and ultimately different lives. In some nearby universes, quantum shifts led you to different conclusions about listening to this right now. In one, you were too tired and decided to sleep. In another, you became fascinated and stayed up all night exploring quantum theory. Elsewhere, you may have dozed off while listening and are now dreaming of parallel worlds instead. Traveling further through this geography, we encounter more substantial changes. In one universe, a tiny quantum fluctuation this morning caused you to feel more confident, prompting a conversation with a stranger that reshaped your day. A different version of you might have made a different career choice years ago due to a small shift in teenage brain chemistry. Or perhaps a quantum event influenced your parents in ways that altered your upbringing entirely. These branching possibilities show how quantum randomness, amplified by time and interaction, can generate completely different life trajectories. The butterfly effect operates even at the quantum level. One change in brain chemistry ripples outward into your choices, your relationships, and your entire future. Move even farther, and the changes become world-shaping. There are universes where key historical events unfolded differently due to quantum decisions made by influential figures. Maybe, in one reality, a random fluctuation prevented the assassination of Archduke Franz Ferdinand in 1914, avoiding the First World War. That world's 20th century might have been marked by peace, producing different technologies, cultures, and even versions of you living a radically different life. In even more distant realities, quantum mutations in ancient DNA altered evolution. Perhaps there are worlds where dinosaurs never went extinct and developed intelligence. Others, where plants became conscious first. Or perhaps life took entirely alien forms, challenging the very idea of what it means to be alive. At what point do these alternate versions stop being you? If your parents never met in another universe, is the person living your life truly you, or simply someone in a similar role. This touches on deep philosophical questions about identity. What makes you the same person across time or across space? Some philosophers suggest that identity persists when memories, personality, and consciousness follow a continuous thread. But in the multiverse, identity may stretch across multiple threads, each one a distinct version of you, shaped by branching possibilities. The anthropic principle helps define the boundaries. It says that we can only exist in universes where conditions support life and consciousness. So, no matter how strange a reality becomes, if you are there, it must allow for some version of you to arise. Still, within those constraints, variations are endless. In some universes, quantum mutations during conception gave you different physical traits, perhaps stronger vision or a different sense of smell. In others, evolutionary paths diverged enough to produce humans with enhanced memory or mathematical ability. Farther still are universes with altered physical constants. Maybe gravity is slightly stronger, or the electromagnetic force is weaker. Most such universes would not support life at all, but a rare few might contain exotic forms of matter or different biological architectures, yet still give rise to conscious beings who experience their world as naturally as you experience yours. In the most distant branches, even the nature of consciousness may change. Perhaps, in some realities, awareness is not tied to a single body but shared across many. Maybe consciousness floats free of matter, or exists as a collective intelligence spanning ecosystems. These selves challenge our understanding of what it means to be you. The quantum immortality hypothesis adds a haunting layer. It suggests that, from a first-person perspective, consciousness never ends. In every life-threatening situation, there's always some branch where you survive. This would mean you subjectively continue to exist indefinitely, even as other versions perish in other timelines. That leads to a troubling thought. Some versions of you may live on indefinitely in realities filled with suffering, trapped by their own survival. These selves raise difficult ethical questions about whether consciousness across the multiverse adds up to a positive experience or a terrifying one. Finally, quantum physicists debate the measure problem, whether all branches of the multiverse are equally real. If they are, every version of you, no matter how strange or distant, is just as real as the one listening now. But if some branches carry more weight, perhaps some selves are more substantial than others. As you contemplate this geography of infinite selves, remember, each version of you, no matter how near or far, feels their reality as fully and vividly as you do now. All of them are exploring different expressions of consciousness. All of them are real. And together, they map out the astonishing landscape of what it means to be you in a quantum multiverse. Chapter 6. Building Bridges Between Worlds. In a laboratory at the University of California, Santa Barbara, physicist John Martinis and his team achieved what once seemed impossible. They built a quantum computer that could maintain coherent superposition across 53 quantum bits. But according to physicist David Deutsch, they did more than just build a powerful machine. They tapped into the power of parallel universes. In an experiment known as quantum supremacy, this quantum computer completed a task in 200 seconds that would take the most powerful classical computer 10,000 years. Deutsch argues that the only explanation for this extraordinary performance is that the quantum system borrowed computational resources from parallel realities, running countless versions of the same experiment simultaneously. This may be the first crude bridge between parallel worlds. While we cannot yet travel or send messages between realities, quantum computers might be creating communication channels that allow information to flow across different versions of our universe. Each quantum calculation becomes a shared task, distributed over infinite worlds. The power behind this lies in quantum superposition. A quantum bit, or qubit, can exist in multiple states at once until measured. Under the many-worlds interpretation, this means that in every universe, the qubit takes on a specific value, but all possible values are realized across many realities. A quantum computer, with 50 qubits in superposition, runs calculations in over a quadrillion parallel worlds at once. These realities collaborate. Each universe explores different paths through the problem. Quantum interference then combines their efforts, amplifying correct solutions and canceling out errors. The final result is the product of countless parallel computations working in harmony. But this may only scratch the surface. A theory called many interacting worlds, proposed by physicists Howard Wiseman and Michael Hall, suggests that parallel universes may not be fully isolated. Instead, subtle quantum forces might allow interactions between them. According to this theory, the strange interference patterns seen in experiments, like the double-slit test, are not merely a particle interfering with itself. Rather, particles in nearby realities are interacting. An electron's interference pattern could be evidence of influence from versions of itself in other worlds. If true, these interactions might be detected under controlled conditions. Researchers have proposed creating ultra-isolated quantum systems to search for deviations from standard predictions, tiny variations that could only be explained by interworld forces. These effects would be incredibly weak, possibly billions of times smaller than any known physical force, but detectable with enough precision. Detecting such interworld effects would not only confirm the existence of parallel universes, but could open the door to controlled communication. By manipulating quantum systems in one world, we could influence corresponding systems in another, creating a form of signaling across realities. This communication would not resemble emails or radio signals. Instead, it would require encoding information in quantum states, with receivers in parallel worlds detecting specific patterns of change. Both sides would need identical systems and deep knowledge of how to interpret these changes. Recent developments in quantum error correction make this concept plausible. These techniques allow quantum computers to preserve information despite interference, making them highly sensitive to very specific effects. Applied to interworld communication, error correction could filter out background noise while amplifying the faint signals from other realities. Some researchers have even proposed that consciousness might already be a natural bridge between worlds. Evidence suggests that biological systems, including the human brain, use quantum processes. If consciousness is partly quantum in nature, as proposed by the orchestrated objective reduction theory, then our thoughts may already be influenced by activity in parallel realities. This could explain sudden insights or intuitive leaps. Our minds might unconsciously draw on the experiences of parallel versions of ourselves. When you solve a complex problem seemingly out of nowhere, it may be because another version of you already found the answer. If so, consciousness might be nature's original method of accessing the multiverse. Instead of being locked into one timeline, conscious beings may sample information across realities, choosing the most useful paths. This possibility shifts the focus from building machines to better understanding the quantum capabilities of our own minds. Techniques such as meditation, altered states, and dream studies might help us tune into this natural interworld awareness. Some studies suggest that trained meditators exhibit unusual patterns of brain activity, possibly indicating enhanced quantum coherence. Dreams, particularly during REM sleep, may also serve as glimpses into the experiences of parallel selves. If dreams allow access to information from other worlds, studying them could move from psychology into experimental quantum science. Comparing dream content with waking experiences might uncover data that cannot be explained within a single reality, offering clues about the multiverse. The benefits of interworld communication could be enormous. We might access technologies, ideas, or medical treatments discovered in parallel timelines. Worlds that solved challenges we still face, such as disease, energy, or conflict, could offer crucial insights. Yet this raises ethical concerns. If we can influence or extract information from other realities, what responsibility do we bear? Are we exploiting alternate versions of ourselves? How do we create ethical systems that respect the autonomy and values of other worlds, especially if their moral principles differ from ours? Security is another concern. What if some realities contain hostile civilizations or dangerous technologies? Sharing information across worlds could invite risks we cannot foresee, including exploitation or conflict. Still, the promise remains. More advanced civilizations in parallel timelines may have answers to our most pressing problems. The key is developing not just the technology, but the wisdom to use it responsibly. Quantum laboratories around the world are already laying the groundwork. Every quantum computer and interference experiment is a small step toward bridging realities. As our tools improve, the walls between worlds may grow thinner. Soon, communication with our parallel selves may no longer be science fiction. The real question is not whether this is possible, but whether we are ready to face the consequences of knowing that infinite versions of us are exploring the same questions, making different choices, and shaping countless worlds in the vast landscape of quantum possibility. Chapter 7. The Consciousness Paradox. Are you all yourselves? As you read these words, something extraordinary is happening within your brain. Approximately 86 billion neurons are firing in precise patterns, generating the electrical symphony that forms your thoughts, emotions, and sense of self. According to quantum mechanics, this neural activity constantly branches into parallel streams of consciousness, creating infinite versions of your mental experience across the multiverse. This leads to a profound question. Are you experiencing just one stream of consciousness in this reality? Or are you experiencing all possible streams simultaneously across infinite parallel worlds? When the universe splits due to quantum events in your brain, does your consciousness split with it? Or does some deeper aspect of your identity persist across multiple realities? This question cuts to the heart of the binding problem, the mystery of how millions of separate neural processes combine to create the unified experience of being a single conscious self. In your brain, different regions are processing visual information, auditory signals, memories, emotions, and abstract thoughts. Yet, you do not experience these as separate processes. Instead, they combine seamlessly into a unified sense of self. But quantum mechanics suggests that this binding might be far more complex than neuroscientists have realized. If consciousness emerges from quantum processes in neural microtubules, as proposed by the orchestrated objective reduction theory, the binding of conscious experience might involve quantum coherence across multiple realities. Consider the act of making a decision. From a classical perspective, competing neural networks battle for control, until one pathway determines your choice. But from a quantum perspective, all possible choices may occur simultaneously in different branches of the multiverse. The neural networks do not just compete. They split into parallel versions exploring every possible outcome. This means that when you decided to continue listening to these words instead of turning off the audio, parallel versions of your consciousness simultaneously made every other possible choice. There are realities where you stopped listening, others where you rewound to hear something again, and still others where you fast-forwarded to a different section. These choices are being experienced by versions of your consciousness across the quantum multiverse. But here's where the paradox becomes mind-bending. Which version is the real you? From your current perspective, it seems obvious that this stream of consciousness, the one processing these exact words right now, is the authentic experience, while the others are somehow less real. But each parallel version of your consciousness feels exactly the same way about their own experience. The version of you who turned off the audio 5 minutes ago is convinced that their choice to stop listening was the real decision, while your current experience of continuing to listen feels like a mere possibility that they chose not to pursue. The version who rewound to hear something again believes their curiosity was the genuine response, while your decision to keep moving forward seems like the path not taken. This creates what philosophers call the problem of subjective indistinguishability. If all parallel versions of your consciousness feel equally real from their perspectives, what makes any particular stream more valid than the others? The answer might be that there is no privileged perspective. Every version of your consciousness is equally real and equally you. This transforms our understanding of personal identity in profound ways. Instead of being a single stream of consciousness moving through time, you might be a vast network of parallel conscious streams, exploring every possible variation of your mental experience simultaneously. But if this is true, why do you only remember one continuous history instead of a jumbled mix from multiple parallel timelines? The answer might lie in quantum decoherence. The process that keeps parallel worlds separate also prevents parallel streams of consciousness from interfering with each other. When quantum events in your brain create splits in consciousness, decoherence rapidly isolates each stream. Each parallel version develops its own coherent memories and experiences, giving the illusion of a single, unbroken thread of conscious experience. You only remember this particular timeline because quantum decoherence prevents access to memories from the parallel streams. However, some researchers suggest that this isolation might not be perfect. Weak quantum connections might occasionally allow information to leak across the boundaries between realities. This could explain phenomena like sudden insights, creative breakthroughs, or intuitive knowledge that can't be traced to specific memories. When you suddenly understand a problem or have a flash of inspiration, you might be accessing information from parallel versions of yourself that explored different thought patterns or encountered different experiences. Your parallel selves become a vast research network, occasionally sharing their discoveries across quantum boundaries. Dreams offer another window into this multi-stream model of consciousness. During REM sleep, your brain exhibits activity patterns that some researchers believe might involve enhanced quantum coherence. If consciousness spans multiple realities, then dreams might be moments when barriers between parallel streams temporarily weaken, allowing experiences and information from other versions of yourself to bleed into your awareness. This could explain why dreams often contain impossible combinations of memories, people, and places. Instead of being random neural noise or wish fulfillment, dreams might be glimpses into the experiences of parallel selves living in slightly different realities. The implications for memory are equally extraordinary. In the classical view, memories are stored as physical changes in neural connections, engrams that preserve information about past experiences. But in a quantum consciousness model, memories might exist as distributed information patterns across multiple parallel realities. This could explain why memories sometimes feel incomplete or inconsistent, why different people remember the same events differently, or why memories can change over time. Instead of being fixed recordings, memories might be reconstructions, assembled from information scattered across multiple timelines where similar events occurred. Near-death experiences provide compelling evidence for consciousness spanning multiple realities. People who near death often report experiences that seem impossible, given their physical condition. Detailed memories of events occurring while they were unconscious, encounters with deceased relatives, or visions of alternate life paths. In the multiverse model, near-death experiences might represent moments when barriers between parallel streams break down. As the brain approaches death, quantum decoherence weakens, allowing access to information from other realities where different versions of your life played out. The beings encountered in these experiences might not be supernatural entities, but parallel versions of yourself and others in nearby realities. The life review, many report, seeing their entire life flash before their eyes, might be a sampling of experiences from parallel timelines where different choices led to different outcomes. This suggests that consciousness is far more resilient and expansive than we usually imagine. Instead of being a fragile property of complex neural activity, consciousness might be a fundamental feature of quantum reality that spans multiple dimensions, surviving the destruction of any particular physical substrate. But this raises profound questions about continuity of identity across parallel realities. At what point do parallel versions of yourself become different people, rather than different aspects of the same identity? If quantum events in your childhood brain led to significantly different personality development in one reality, is that version still you? The answer may depend on the level of consciousness we're considering. At everyday levels, thoughts, emotions, and decision-making, parallel versions might diverge enough to become distinct people. But at deeper levels, there might be aspects of identity that persist across all parallel realities. This model suggests that practices like meditation, which access deeper levels of consciousness, might allow you to connect with the unified awareness that spans all your parallel selves. Advanced spiritual practitioners have described experiences as that sound similar to quantum consciousness models, feelings of oneness, knowledge beyond normal learning, and the ability to influence reality with consciousness alone. But the multi-stream model also raises disturbing implications. If every version of your consciousness is equally real, then somewhere in the multiverse, versions of you are experiencing suffering, trauma, and failure. For every moment of joy in this reality, there are countless versions of you experiencing pain. This leads to profound questions about the net value of existence across the multiverse. Is the total sum of experiences across all parallel selves positive or negative? Are the moments of happiness worth the inevitable suffering elsewhere? The consciousness paradox challenges us to expand our understanding of what it means to be human in a quantum universe. You might not be a single stream of consciousness in one reality, but a vast network of parallel selves exploring every possible variation of existence simultaneously. The boundaries between self and other, between individual and universal consciousness, might be far more fluid than we ever imagined. As you reflect on these possibilities, remember that simply contemplating consciousness across multiple realities might be changing your relationship to those parallel streams. By becoming aware of the quantum nature of consciousness, you might be developing the ability to access insights from your parallel selves, expanding your understanding and capabilities. Chapter 8. The Paradox of Choice in a Deterministic Multiverse. Tonight, as you listen to these words about parallel worlds and quantum consciousness, you made thousands of choices. You chose to keep listening instead of stopping. You chose to focus on certain ideas while letting others drift away. You chose specific thoughts and reactions in response to what you heard. But if the many worlds interpretation of quantum mechanics is correct, every choice you did not make was simultaneously made by parallel versions of yourself in other realities. This creates one of the most profound paradoxes in quantum philosophy. If all possible choices occur somewhere across the multiverse, do individual choices matter at all? If there exists a reality where you made every possible decision, what significance remains in the particular choices you make here? Are you truly free to chart your own path, or are you simply experiencing one predetermined thread in an infinite tapestry of parallel possibilities? This question cuts to the core of human meaning and moral responsibility. Historically, ethics, laws, and personal identity have rested on the assumption that choices carry consequences, and individuals are responsible for their decisions. Yet, in a multiverse where every choice branches into parallel realities, the foundation of moral thinking is thrown into uncertainty. Consider a simple example. Tomorrow, you may decide whether to help someone in need. In a classical universe, your choice determines whether that person receives aid or continues to struggle. Your decision holds clear moral weight because it directly affects another person's well-being. But in the many worlds multiverse, both outcomes occur simultaneously. In one reality, you help. In another, you do not. The person receives assistance in some worlds and suffers in others, regardless of what you personally choose. This seems to imply that individual moral choices are meaningless, since all possible outcomes happen anyway. If there is always a parallel reality where you make the opposite choice, why feel responsible for the particular choice you make here? Why should guilt, pride, regret, or satisfaction accompany decisions if every alternative is equally real somewhere else? However, this reasoning contains a subtle error that reveals something profound about choice in quantum mechanics. While it is true that all possible outcomes occur across the multiverse, the pattern of how those outcomes are distributed matters enormously. Your choices do not determine whether helping or not helping occurs. They determine which type of universe you contribute to creating. When you choose to help someone, you are not just affecting that person's welfare in this reality. You are contributing to the measure, the relative probability or weight, of realities where compassionate behavior occurs. In the vast landscape of parallel worlds, your choice increases the prominence of universes characterized by kindness and cooperation, while reducing the influence of realities dominated by selfishness and indifference. This perspective transforms moral responsibility from a classical notion of single cause and effect into a quantum concept of probability, shaping across infinite realities. Your choices do not create unique outcomes, but they influence the overall character of the multiverse by determining which types of realities become more or less likely to be experienced by conscious observers. Quantum mechanics supports this interpretation through what physicists call the Born rule, the formula that determines how quantum probabilities translate into observable outcomes. According to this rule, the choices made by conscious observers affect the relative measure of different branches in the multiverse, making some realities more probable than others. When you make ethical choices, you are essentially voting for the type of multiverse you want to exist. Each decision adds weight to branches, where similar choices are made by parallel versions of yourself and others. Over time, the accumulated choices of conscious beings across the multiverse shape the overall nature of reality, determining whether most conscious experience occurs in realities characterized by suffering or flourishing. This quantum approach to ethics suggests moral responsibility operates on multiple levels simultaneously. At the individual level, you are responsible for determining which branch of reality you personally experience. At the collective level, you participate in a vast, collaborative project shaping the overall nature of conscious existence across all possible worlds. But this framework also creates new categories of moral consideration absent from classical ethics. If your parallel selves in other realities are making different choices, do you bear any responsibility for their actions? Are you morally connected to versions of yourself who make harmful decisions, even if you personally choose differently in this reality? Some philosophers argue that moral responsibility extends across all parallel versions of a person because they share the same fundamental identity and decision-making processes. From this view, the version of you who helps someone shares moral credit with parallel versions who make similar choices, while also sharing moral burden with versions that choose selfishly. Others contend that moral responsibility is limited to the specific choices made in each particular reality. In this view, you are accountable only for the decisions you actually make, not for the choices of parallel selves existing in different quantum branches. Each version of yourself is morally independent, responsible solely for their actions within their own reality. The question grows even more complex when we consider quantum indeterminacy, the fundamental randomness at the heart of quantum mechanics. Many quantum events that create branching in the multiverse are truly random, with no underlying cause or pattern determining their outcomes. This randomness plays a crucial role in neural processes, influencing everything from neurotransmitter release to the timing of electrical signals in the brain. This means some differences between parallel versions of yourself arise from pure chance, rather than conscious choice or decision-making. Random quantum fluctuations in your brain chemistry may tip the balance toward different emotional responses or thoughts, leading to varying behaviors even when your conscious intentions remain the same. If quantum randomness influences your decisions, can you be held fully responsible for your choices? Classical free will assumes agents have complete control over their actions, but quantum mechanics suggests random events beyond anyone's control significantly shape behavior. This does not eliminate moral responsibility entirely, but it complicates how we assign credit and blame for human actions. The therapeutic implications of understanding choice in a multiverse context are profound and complex. On one hand, knowing all possible versions of your life exist somewhere in the quantum multiverse can be deeply comforting. If you struggle with regret about past decisions, you may find solace in knowing parallel versions made different choices and are experiencing the outcomes you wish you had. if you are coping with loss or tragedy. The multiverse perspective suggests there are realities where those painful events never occurred. Parallel versions of yourself live happier lives where loved ones remain. Accidents did not happen, and opportunities were not missed. This knowledge does not erase the pain of loss in this reality, but it can provide a broader context that makes suffering more bearable. Similarly, if you face difficult decisions about the future, the multiverse framework can ease the pressure by ensuring all possible paths are explored by parallel versions of yourself. You do not have to worry about making the single right choice, because all choices will be made simultaneously across different realities. Yet, this perspective can also be psychologically challenging. If all outcomes occur regardless of personal choices, some might develop a sense of fatalism or nihilism that undermines motivation and engagement. Why strive for goals or self-improvement if parallel versions are already achieving every possible outcome? The key to maintaining psychological health while embracing the multiverse perspective is understanding your choices determine which reality you personally experience, even if they do not determine which realities exist. While parallel versions might achieve different outcomes, you have direct access only to the thread of experience following your decisions. This means choice remains meaningful for your personal experience, even in a deterministic multiverse. The version of yourself making healthy choices will experience better physical and mental health. The version cultivating relationships will experience more connection and love. The version pursuing growth will experience greater understanding and capability. Quantum decision theory offers a mathematical framework for making choices in a multiverse context. Instead of maximizing a single outcome, it suggests optimizing across the distribution of parallel realities resulting from different choices. This approach considers not just the best-case scenario, but the probability and measure of various outcomes across multiple worlds. For example, when deciding whether to take a risk, you would consider how the decision affects the overall distribution of outcomes across all parallel realities where similar choices are made. Some choices might lead to better outcomes in specific realities, but create worse overall distributions across the multiverse. This quantum approach to decision-making can produce choices that seem counterintuitive from a classical perspective. It might be rational to accept certain risks or sacrifices in this reality, if doing so improves overall outcomes across the broader multiverse. Conversely, it might be wise to avoid some opportunities if they increase the probability of negative outcomes across parallel worlds. Perhaps the most profound implication of choice in a multiverse concerns personal growth and self-improvement. In classical thinking, you work to change yourself over time, becoming wiser, kinder, or more capable. But in the multiverse framework, personal development takes on a different meaning. Instead of changing yourself linearly through time, you explore the full space of what you could become across parallel realities. Each choice does not just affect your future. It determines which version of yourself you align with among infinite possibilities already existing in the multiverse. This perspective suggests self-improvement is less about creating new capabilities and more about selecting which existing possibilities to manifest in your personal experience. The wise, compassionate, accomplished version of yourself already exists somewhere in the quantum multiverse. Your choices determine whether you move toward or away from alignment with that optimal version. Living with awareness of choice in a deterministic multiverse requires embracing a paradoxical mindset. Acting as if your choices matter completely while understanding all possibilities occur regardless. You must take full responsibility for your actions while recognizing quantum randomness influences every decision. This paradox mirrors the fundamental nature of quantum mechanics itself, where particles exist in multiple states simultaneously until observation collapses them into single outcomes. Likewise, you exist as multiple possibilities simultaneously across the multiverse, with your choices determining which possibility you consciously experience, rather than which possibilities exist. The ultimate resolution of the choice paradox might be recognizing the question itself reflects classical thinking that does not fully capture quantum reality. In a multiverse where consciousness spans multiple realities, the boundary between self and other, between individual choice and universal determinism, between freedom and fate, becomes fluid and contextual rather than fixed. You are simultaneously the author of your own story and a character in a vast narrative containing all possible stories. Your choices matter infinitely because they determine your personal experience, and they matter not at all because every alternative unfolds somewhere else in the endless library of parallel realities. This paradox is not a problem to be solved, but a deeper truth about existence in a quantum universe where consciousness creates reality by choosing which aspects of infinite possibility to experience and explore. Chapter 9. Tonight, as you sleep, a meditation on infinite dreams. Tonight, as you prepare to let your consciousness drift into sleep, consider this astonishing truth. In countless parallel realities, other versions of you are already dreaming. Some fell asleep hours ago. Others are just now closing their eyes. And still others have chosen to remain awake throughout the night, exploring thoughts and experiences that will never touch your waking awareness. Each version believes their choice about when and how to sleep is the single true decision, unaware that every possible variation is unfolding simultaneously across the quantum multiverse. The transition from waking consciousness to sleep is one of the most mysterious processes in human experience, and quantum mechanics suggests it may be even stranger than we imagine. As your brain chemistry shifts toward sleep, patterns of neural activity change in ways that could alter how consciousness navigates the branching structure of parallel realities. During the day, your waking mind stays tightly focused by constant sensory input and active decision-making. This flood of information anchors your awareness to a single thread of experience, reinforcing the illusion that you exist in only one reality. But as you drift toward sleep, this coherence begins to relax, possibly allowing your consciousness to sample information from parallel streams more freely. Sleep involves dramatic shifts in neurotransmitter levels. Acetylcholine decreases while GABA increases, producing brain states fundamentally different from waking awareness. If consciousness involves quantum processes in neural microtubules, these neurochemical changes might affect how quantum coherence operates in your brain. Instead of maintaining a rigid focus on a single reality, a sleeping consciousness may naturally drift between parallel streams of experience. The strange, impossible combinations of people, places, and events that fill dreams might not be random neural noise, but glimpses into the lives of parallel selves in slightly different realities, worlds where events unfolded differently and relationships took alternative forms. Think of dreams where deceased loved ones appear alive, where you dwell in houses blending features from multiple real locations, or where you possess abilities and knowledge you do not have in waking life. Traditional neuroscience explains these as memory fragments randomly recombined. But quantum consciousness theory suggests they may be windows into parallel realities where these impossible combinations are normal. In some parallel worlds, the people you have lost might still be alive because quantum events prevented accidents or illnesses. The houses in your dreams might be actual homes of parallel versions of you who made different choices. The abilities you experience might reflect skills developed by your counterparts through alternate life paths. This perspective transforms sleep from unconscious neural maintenance into an opportunity for consciousness to explore the vast landscape of quantum possibilities normally hidden during waking life. Each dream becomes a journey through parallel realities, offering glimpses of how your life might have unfolded under different circumstances. But the quantum nature of sleep and dreaming goes beyond observation. Some researchers propose that sleeping consciousness might actively participate in creating new quantum branches through choices made within dreams. When you decide in a dream to flee danger, approach someone, or explore a place, you might be creating new branches in the multiverse just as surely as waking decisions split reality. This suggests your dream life is not separate from your waking existence, but represents another dimension of conscious exploration, contributing to the overall pattern of your identity across the multiverse. The choices you make in dreams might influence which parallel realities become accessible to your consciousness, creating feedback loops between sleeping and waking experience that shape your journey through quantum possibility. The timing of sleep itself creates branching points across parallel realities. In this universe, you chose to listen to these words before drifting into sleep, but countless versions of you made different choices about when to rest, what to think before sleeping, and how to prepare for unconsciousness. Some parallel selves went to sleep hours earlier and are now deep in REM cycles, experiencing dreams influenced by quantum events you have yet to encounter. Others stayed awake longer, just beginning to feel drowsy as sunrise approaches in their timelines. Still, others chose not to sleep at all tonight, remaining conscious to observe how thoughts and perceptions shift, while most versions of themselves are unconscious. These different sleep schedules create unique neural activity patterns that might affect how consciousness navigates quantum branching. The version of you who sleeps early experiences different neurochemical cycles than the one who stays up late. These differences influence dream content, problem solving, emotional processing, and ripple across all aspects of parallel existence. The content of your dreams tonight will be shaped by quantum events occurring in your sleeping brain. Random quantum fluctuations in neurotransmitter systems may determine whether you dream of past events or imaginary scenarios, whether your dreams are pleasant or unsettling, whether you remember them upon waking or lose them instantly. But these quantum events do more than affect your individual experience. They create parallel realities where infinite versions of you have infinite variations of dreams. In some worlds, you will have peaceful dreams that leave you refreshed and hopeful. In others, nightmares will generate anxiety and unrest. Most will experience the complex, contradictory mixture typical of normal sleep. Each variation contributes to the overall landscape of conscious experience across the multiverse. The universe uses sleeping consciousness to explore emotional and psychological territories too intense or disruptive for waking life. Through dreams, consciousness can safely experience death, transformation, impossible achievements, and catastrophic losses without real-world consequences. This may explain why dreams often involve extreme emotions, and dramatic scenarios beyond everyday life. Sleeping consciousness gravitates toward the edges of possibility, exploring the full range of human experience across all potential realities. Your dreams tonight add your unique perspective to this infinite library of conscious experiences. Meditation practices from spiritual traditions may enhance awareness of the quantum nature of sleep and dreaming. Lucid dreaming, the ability to maintain awareness during dreams, might be a natural skill for navigating parallel streams of consciousness. Experienced lucid dreamers who control dream content and explore impossible scenarios may be demonstrating conscious navigation of quantum possibility space. Advanced meditators often describe sleep as an opportunity for consciousness to rest in its fundamental nature, free from the structures that organize waking experience. From a quantum view, this may involve accessing awareness, spanning multiple realities, experiencing consciousness itself, rather than particular contents that vary across worlds. Practices like Yoga Nidra, or conscious sleep, teach how to observe consciousness shifting between quantum coherence states. Instead of losing awareness while falling asleep, practitioners witness the reorganization of consciousness for different experiences. These teachings suggest the boundary between sleeping and waking consciousness is less fixed than it appears. With training, it may be possible to maintain continuous awareness across states, potentially accessing information from parallel realities usually available only during sleep. Even without special training, everyone's natural sleep cycle represents quantum consciousness exploration, contributing to the evolution of awareness across the multiverse. Your dreams tonight are unique experiments in consciousness, adding to the vast database of experiences that exist across all parallel worlds. As your consciousness shifts into sleep, it embarks on journeys spanning multiple realities, exploring impossible scenarios and contributing to the infinite creative evolution of awareness in a quantum universe. The version of you falling asleep now is just one of countless selves preparing for unique dream explorations across the vast landscape of parallel possibilities. The beauty of this quantum view of sleep and dreaming is not in replacing mystery with mechanistic explanations, but in revealing that the mystery runs even deeper than imagined. Sleep becomes a gateway to infinite realities instead of mere neural maintenance. Dreams become explorations of parallel worlds rather than random firing of neurons. Consciousness reveals its true nature as something far vaster and more connected than any single brain or reality. Tonight, as infinite versions of you drift into infinite variations of sleep and dreaming, consciousness continues its eternal exploration of what it means to exist, experience, and be aware in a universe where every possibility finds expression, and every dream contributes to the endless creative evolution of existence itself. Rest well, knowing your sleep is both deeply personal and cosmically significant, both individual and universal, one experience among many, and an irreplaceable part of the infinite symphony of consciousness, exploring its unlimited nature. Still here, friend? If your eyes are getting heavy, it's okay to let them close. Your mind remembers the way. But if you're still awake, there's another video waiting for you. I'll be here if you'd like a little more company. Either way, thank you for spending your night here. May your dreams be calm, your breath gentle, and your thoughts float softly like stardust. Sleep well among the stars.